They are among the biggest explosions of radio energy in the entire universe. The energy in radio frequencies is so great that eventually the entire universe will be aware of this one explosion.
Welcome, stargazers. Can you believe it? Imagine a celestial event so monumental that it casts shadows on Earth, visible even in broad daylight. That's the spectacle we might be on the brink of witnessing. Located in the Orion constellation, the star Betelgeuse is acting mysteriously, hinting at an impending supernova explosion that will light up our sky like never before. But when will Betelgeuse go supernova, and what will it look like according to scientists? And what secrets might this stellar event unveil? Join us as we delve deep into the details of what's really going on with Betelgeuse and the impact it might have on Earth, and perhaps for the entire solar system. Located approximately 650 light-years from Earth in the constellation Orion, Betelgeuse is not just any regular star. It's a red supergiant, one of the most luminous stars known to us, shining with a brightness over 100,000 times that of our Sun. But why does this red giant matter so much to us? Well, Betelgeuse stands out, not only for its brightness, but also for its history and significance in human culture. Named after the Arabic term Yad al-Jawza, which means the hand of Orion, Betelgeuse has been observed and documented by ancient civilizations. For centuries, it has been a guide for travelers and a point of wonder for stargazers, with its reddish hue distinguishing it from other stars in the Orion constellation. Can you imagine a single star dwarfing our entire solar system? To provide some perspective on the sheer enormity of Betelgeuse, if it took the place of our Sun, its edges would extend all the way to Jupiter. How can a single star achieve such colossal proportions? At 10 million years old, it's a lot younger than our 5 billion-year-old Sun. But Betelgeuse's massive size means it consumes its materials at a much faster pace, predicting a shorter lifespan than that of other stars. Now, this celestial behemoth, spanning a volume large enough to contain more than 1 billion of our suns, is nearing the end of its life cycle. And when stars of such magnitude reach their twilight years, they don't just fade away. They go out with a bang, a supernova explosion that's beyond human comprehension in terms of its energy and brilliance. Such an event has the potential to outshine an entire galaxy, casting shadows of brilliance across vast cosmic distances. The last time Earth witnessed a supernova explosion this close was in 1604, long before the invention of modern telescopes. This event, known as Kepler's supernova, was the last supernova to be observed in our Milky Way galaxy with the naked eye. Visible for over 18 months, it was brighter than any other star in the night sky and even remained visible during the day for several weeks. What mysteries do these stellar remnants reveal to us? Ancient records from various civilizations, including Chinese and European astronomers, documented the appearance of this new star. Intriguingly, remnants of this explosion, in the form of an expanding debris cloud, can still be observed today with sophisticated telescopes, giving us insights into the violent ends of massive stars. Historically, supernovae have been rare observers on Earth. But imagine for a moment a stellar detonation so intense that it rivals the brightness of a full moon, casting shadows on Earth at night and being visible during daylight. The radiation from such an event would charge our atmosphere, potentially impacting satellite operations and possibly even the climate. Betelgeuse, with its unpredictable dimming patterns, suggests it might be gearing up for just such a grand spectacle. Could we be on the verge of witnessing one of the universe's most dramatic events? Just now, astronomers have made a startling revelation. Between October 2019 and early 2023, Betelgeuse underwent a remarkable transformation that drew the attention of astronomers and enthusiasts worldwide, known as the Great Dimming. The star's brightness, which had been consistent for centuries, began to decrease significantly. This sudden change was so evident that even casual stargazers noticed it when comparing Betelgeuse to other stars in the Orion constellation. And it means that we're not just centuries away from witnessing its supernova explosion, but perhaps mere decades or even less. By April 2023, the astronomical observations reported that Betelgeuse had returned to its standard luminosity levels, leading many to believe that the period of anomaly had ended. Yet, in a startling turn of events, the subsequent months saw Betelgeuse's brightness amplifying by an astonishing 50%. Such marked fluctuations, while typical of variable stars, were uncharacteristic for a star like Betelgeuse, which had largely displayed predictable luminosity cycles. The sudden and intense surge in its brightness propelled the star back into the limelight, prompting discussions about its immediate future. But why the sudden change in brightness? Why did Betelgeuse, one of the most recognized stars in our night sky, suddenly throw a celestial curveball? Stars are not just twinkling dots in our night sky, they are dynamic entities with life cycles, activities, and mysteries of their own. For many celestial bodies, periodic brightness variations can be predicted, much like the rhythms of Earth's seasons. In its stellar lifetime, Betelgeuse has clocked in a fairly consistent 400-day luminosity cycle. But with the great dimming, it seemed to rebel against its known nature, challenging our understanding of the celestial wonders above. Now, you might be wondering, are we on the brink of a stellar revelation? While the exact reasons for Betelgeuse's irregularities are still under investigation, a compelling theory has emerged. This theory, centering around stellar activity and mass ejection, proposes a tantalizing scenario. Imagine Betelgeuse as a giant celestial volcano, suddenly erupting and spewing a colossal amount of its matter into space. In the past, observations from the Hubble Space Telescope unveiled that Betelgeuse has previously ejected an enormous amount of its surface material into the cosmos. This ejection, a colossal event, was 400 billion times the mass typically released during similar solar phenomena, equivalent to several times the mass of our Moon. Such events can lead to the formation of a dense dust cloud around the star, affecting its apparent brightness and making it temporarily harder to observe. Then, once this dust began to disperse or was pushed away by the force of the star's radiation pressure, the veil lifted. This could explain its subsequent return to regular brightness levels. Either way, these recent events hint at a star that's not done with its surprises. Many speculate that Betelgeuse might be approaching the twilight of its life, a supernova event. A supernova is a cataclysmic explosion, an astounding burst of energy that can outshine an entire galaxy momentarily. This phenomenon occurs when there is a sudden change in the star's core. Such changes can arise if a star absorbs too much matter from a neighboring star, or in Betelgeuse's case, it could be from the exhaustion of its nuclear fuel, which cascades its mass into the core, setting the stage for a cataclysmic collapse. But what drives a massive star like Betelgeuse to its demise? Born from the gravitational collapse of gas within molecular clouds, stars like Betelgeuse kickstart their journey by burning hydrogen in their cores. This initial phase, known as the main sequence stage, lasts for millions of years and forms the backbone of a star's life. But as stars run low on hydrogen, they evolve, embracing new energy sources. In the case of Betelgeuse, as the hydrogen depletes, it begins to burn helium, leading to the formation of carbon and oxygen. This transition from the main sequence phase to the helium-burning phase is marked by the star's expansion into a red giant. With time, as helium reserves diminish, the star undergoes further expansion and shifts into other burning phases, each characterized by the fusion of progressively heavier elements. The bigger the star, the quicker these transitions, given the immense gravitational pressures at play. Then comes the climax, when iron starts forming at the core. Unlike lighter elements, iron doesn't release energy when fused, so the energy produced isn't enough to resist the star's own crushing gravity. The star balloons in size and creates an implosion, followed by a massive rebound effect, resulting in the explosive force of a supernova. So, is Betelgeuse on the brink of an explosive end, or just biding its time? Recent research by Japan's Tohoku University suggests that the star might be in its carbon-burning phase right now. Lead researcher Hideyuki Sayo believes that the core might collapse a few decades after its carbon reserves dry up. But not all scientists agree. Contrasting studies from Hungary's Konkoly Observatory speculate that Betelgeuse is still in the earlier helium-burning stage. The one thing that scientists do agree on, regardless of these debates, is that Betelgeuse is slated to become the Milky Way's next supernova. Yet, pinning down the timing of this event remains a cosmic guessing game, with bets ranging from mere decades to 100,000 years. Amidst these scientific debates and speculations about Betelgeuse's fate, one fact remains unchallenged: the very nature of our observations. When we look up at the starry expanse, there's a subtle paradox we often overlook. This paradox is rooted in the very nature of time and light in our vast cosmos. Stars and celestial bodies are so distant that their light takes a momentous amount of time to reach our eyes. For instance, the light speed, while being an astounding 186,282 miles per second, still has its constraints. Consequently, the light from remote stars and galaxies takes its sweet time to traverse the vastness of space before it graces our sight. Gazing at Betelgeuse, you're actually witnessing a spectacle from 650 years in the past. To put that in perspective, when this very light embarked on its journey toward Earth, the Renaissance was just dawning, and explorers like Marco Polo were making their mark in history. Every observation we make of Betelgeuse is like looking through a cosmic time capsule, granting us insights into its distant past. And if, for argument's sake, Betelgeuse had already exploded in a magnificent supernova, we'd remain oblivious for another 650 years. So, while we discuss and predict its impending supernova somewhere out in the vast cosmos, this monumental event might have already unfolded. We're just waiting for it to traverse space and time until it reaches our eager telescopes. The recent revelations around Betelgeuse have led to fervent discussions in the astronomical community, with comparisons being drawn to another sensational discovery from earlier this year, SN 2023 IXF. This recently observed supernova, occurring in a galaxy neighboring the Milky Way, reminded many of the fascinating dynamics and unpredictable nature of the universe. SN 2023 IXF was unique in its own right. Located several million light-years away, it showcased an intense display of brilliance that momentarily outshone its host galaxy. But what made it particularly interesting to scientists and casual observers alike was its uncanny resemblance to what many predict will be the fate of Betelgeuse. The spectrum, intensity and aftermath of the explosion offered a tantalizing glimpse into the processes that these massive stars undergo as they approach the end of their life cycles. For many, SN 2023 ISF served as a preview. If and when Betelgeuse meets its explosive fate, the sequence of events may look similar to what was witnessed with SN 2023 IXF. In addition, the connection between these two celestial events underscores a broader theme about the interconnectedness of our universe. Whether it's a neighboring star like Betelgeuse or a distant supernova such as SN 2023 ISF, these cosmic phenomena remind us of the dynamic and evolving nature of space. The realm of space exploration is full of uncharted territories and unsolved mysteries, and nowhere is this more evident than in our understanding of red supergiants like Betelgeuse. As brilliant as they are enigmatic, these celestial giants hide some of the universe's most profound secrets. At a fundamental level, the life cycle of red supergiants, though charted, is punctuated with ambiguities. While we know that these stars evolved from the main sequence phase to their grand supergiant stature, the intermediary processes are less understood. These phases, which might involve tumultuous upheavals in the star's core, are still subjects of intense research and debate. Second, red supergiants are known for shedding massive amounts of material in their later stages. This process is crucial in shaping their evolution and eventual supernova explosions. Yet how they lose this mass, at what rate, and what triggers these outbursts remains unclear. Betelgeuse, with its recent fluctuations, only adds to this prevailing uncertainty. So what are the implications of a Betelgeuse supernova? At the heart of this cosmic drama, an event of stellar proportions is set to occur. Dr. Stanimir Mechev from Western University suggests that when Betelgeuse does finally explode, it will momentarily be one of the brightest objects in our sky, outshining all other stars and possibly even some planets. For context, even at its vast distance of 650 light-years, The luminosity could rival or even surpass that of the moon. Night would turn into a pseudo-day for weeks or possibly months. This blinding display would last for weeks, forever changing our perception of the constellation Orion. Following months would see this luminosity fade, and after decades, an outer shell of the once vibrant star would present itself as a planetary nebula surrounding the dim remnants of its core. Astronomers and astrophysicists worldwide are evaluating the potential effects of such a spectacle on Earth. There's some speculation that an explosion could release cosmic rays, high-energy particles that travel through space at nearly the speed of light. These particles would race across space, potentially colliding with interstellar material and ionizing it, leaving a trail of charged particles. When these cosmic rays approach Earth, they could interact with our magnetosphere, producing some gorgeous auroras. But does this mean we're likely to face some serious consequences here on Earth? Thankfully, Betelgeuse is far enough that these rays would likely be diluted and absorbed by our atmosphere, ensuring minimal impact on our planet's biosphere. While the explosion itself won't pose a direct threat to Earth, the cosmic light show will undoubtedly spark conversations, research, and possibly even concerns. But what about our man-made marvels hovering above the surface of the Earth? The surge in brightness, coupled with potential gamma and X-ray radiation, could have implications for satellite operations, especially those in higher orbits. There might be a need for protective measures to ensure that our satellite infrastructure remains unaffected by the high-energy particles from the explosion. Furthermore, scientists would monitor the Earth's atmosphere closely, studying any potential impacts from the increased radiation. It's possible that the echoes of this event could also have some unexpected consequences. Have you ever imagined what the distant explosion of a star might sound like? Although we think space is totally silent, thanks to the vacuum that prevents the propagation of sound waves, the explosion of a star is no muted affair. Supernovae, like Betelgeuse, can trigger fluctuations in the charged particles present in space, an event that can be described as an acoustic signature. This isn't sound in the traditional sense, but a manifestation of the explosive turbulence as it resonates through space. And because this signature lies far beyond the auditory spectrum that human ears can pick up on, scientists use specialized tools to help them detect these low-frequency oscillations. These sounds offer a unique perspective into a supernova's explosion, allowing researchers to gather knowledge on energy transmission in a vacuum. But even before the ripples of sound, there might be another cosmic messenger racing towards us. Before we'd even witness the majestic light display from the Betelgeuse Supernova, our planet would be bathed in an invisible rain, a burst of neutrinos. Neutrinos are elusive, near massless particles that have an uncanny ability to pass through matter virtually unhindered. This means that when a star like Betelgeuse explodes, these neutrinos are among the first messengers to relay the news. Enormous specialized neutrino observatories deep underground or submerged in water are primed to detect these sudden surges. This early warning system could provide researchers with a few precious hours of preparation before the full luminosity of the supernova becomes visible. But these particles don't tell the whole story. Immense celestial events like supernovae are also believed to generate ripples in space-time known as gravitational waves. When we think of space, we often visualize a vast, unchanging expanse. But Albert Einstein's theory of general relativity introduced us to a concept where space isn't just a passive backdrop, it's an active participant. If Betelgeuse were to explode, it's anticipated that these gravitational waves would ripple outwards from the point of the explosion. Detecting and studying these waves would not only confirm predictions made by general relativity, but also add a new layer of understanding to the mechanisms at play during the supernova. How would other life forms in our universe react to such a blinding spectacle? If extraterrestrial life does exist in other systems, the supernova could have profound impacts. Planets near the exploding star might face dramatic changes in their climate due to shifts in light and energy, upending the habitats of any nocturnal species. And without protective measures like a strong magnetic field or dense atmosphere, the brunt of radiation from the explosion could reshape ecosystems or even alter evolutionary trajectories. Finally, what becomes of a star once it has dazzled the universe with its explosive finale? It embarks on a new journey, and what this journey looks like depends largely on the star's mass. If the core is sufficiently massive, it could collapse under its own gravity, giving rise to a black hole. This entity would exert such a tremendous gravitational pull that not even light could escape its grasp. Conversely, if the core isn't massive enough, it could become a neutron star, which is an incredibly dense body primarily composed of neutrons. Neutron stars are so dense that a teaspoon of their material would weigh billions of tons on Earth. Witnessing the birth of either a black hole or a neutron star from the remnants of Betelgeuse would be a monumental moment for astronomy, allowing us to observe and understand the final stages of stellar evolution up close. Beyond the tangible and scientific, the explosion would have profound effects on human culture. The sky, observed and revered for millennia, would have changed. This alteration would lead to reflections on impermanence, the vast scales of cosmic time, and our place in the universe. Such cosmic wonders remind us of the ephemerality of existence and our eternal quest to comprehend the great beyond. Thanks for watching this episode of Beyond Discovery. Don't miss the video you see on your screen. You won't believe it.